Okay, so here's the next question. I think we're live. Let me see. Where is the... I'd like to know where this is playing live. That way I could easily post this. Okay, there we go. So this is the URL. I would post it to Twitter, I guess. But I'm actually not going to post that to Twitter here. So we're just, I guess we're streaming live now on the next question. And let me see. Oops. I didn't hit Discord. Shoot. All right. So we have the chat open here. I think we refresh the chat so that way. Yeah, I think we're okay. Let me close Discord. I need to have this open here. That's really annoying. Given a binary tree, imagine yourself standing on the right side of it. Return the values of the nodes you can see ordered from top to bottom. Given a binary tree, imagine yourself standing on the right side of it. Return the nodes of the values you can see ordered from top to bottom. Oh, that's interesting. Wow, I like that. Okay, I don't want to be leaking stuff. My Discord. Wow, pretty interesting question. I think this is a really simple loop. I think this is as simple as just, print the root, and then print the right node, and then recurse on the right node. We could probably just iteratively as well. But it would be recurse on the right node if it exists. Otherwise, recurse on the left node. We could do that. We could try it recursively first. So give that a shot. And we're going to say something like this. We want to say base case and otherwise you're going to say if ret.push back root val, say if root right, then recurse, or no, f on root right f, otherwise recurse on root left. Something like this. Okay, let's go for it. See how we do. I'm not gonna. I don't want to think. Not even think about it. Oh, wrong algorithm. I could have used some test cases. It's true. It's true. I should have. Probably should have. I don't know. I kind of just wanted to be really quick about it, I guess. Oh, no kidding. Oh, it's wrong, the algorithm. Yeah, okay, that makes sense because it's the rightmost node at every level. Ooh. Whoops. Okay, fair enough. I didn't think about that. Okay. Good question. Makes you think. I got it wrong. Didn't really think long enough about it. Ouch. Ouch. Alright. Fair enough. Fair enough. Alright, so how do we get the rightmost node at each level? You can use a breadth first search. I think is the best way to do it. Just thinking, breadth first search is one way of doing it. Okay. I think I got it. So yeah. Okay, that's the way. One way to do it. So you can use a breadth first search and process the search level by level, which is kind of an interesting way to do it. So we're gonna use a double for loop for that one. This should be interesting. It should be interesting. So we'll use a queue. I think in C++ is, what are these for queues? Yeah, just a queue. Queue. There's front, back, push pop. Yeah, okay. And we're going to use tree nodes. And we're going to say initially the queue is going to be push the root. And I'm not sure what the outer loop is going to look like, but the inner loop, we're going to, what we want to do is loop over everything in the queue and push into the queue. It's sort of in one shot. So this is going to be interesting. So we actually have another queue. There's a few ways to do this, but we can do another queue. I'll call that temporary. And we're going to say for queue.empty, not empty. And we say tree node x, say queue.front, and then we'll say so x is the front initially, and then we're going to pop and x equals queue.front. Not quite right. You have to make sure that it's empty. That's not empty. You can leave this part out, I think. Push an attempt x left, x right, and then we say we're going to update x with so queue.pop, and if not queue.empty, x equals queue.front. I feel like I'm kind of I feel like I'm forcing the this for loop, but I like for loops if I can get them in there. It's kind of fun. So what you're gonna do, and then we have what you're gonna do is this temporary queue, you're going to ret pushback temp back value. And you also want to check that these are not null also. Right. I think you can actually do something like this. I should probably just do a while loop. Yeah, we'll just do a while loop. It's fine. For loops are fun, but I think a while loop is just better for this. And what we're going to do then is use assignment operator, assignment constructor to move this temp into queue. So this becomes the new sort of level. And there's also going to be a while loop, which is we'll say while queue is not empty. And the idea here is also, can you, yeah, you can see what I'm doing here, right? I think it's, hopefully my face cam isn't too obnoxious. I don't think it is. Yeah. The idea here is you're gonna do a level by level search, and you're gonna push at each level. You're gonna push, sort of create like an array of all of the of all of the nodes at each level. I actually don't know what this is gonna look like here. Runtime error. Something went wrong. Whoa. Memory cannot be printed undefined behavior. Oh no. Oh. Of course. Oh no. Temp is here. Ret's here. Temp.backval. Oh. Yeah. Okay. I just need to say if temp is not. Yeah, I think that might be it. Wrong answer. There is something funky going on here where I want to say, like, I have all these checks for things being empty and things being null. That's actually what I'm missing. I'm missing the I didn't put the root into the return vector, which is what I was supposed to do. That would fix this, right? If I just But I want to say there's a better way to do this than doing it this way. So I think this is correct now, although this is definitely not. I'm a little bit embarrassed that I got this wrong initially. I don't really like how I coded this. This is like not super clear, I guess. And I should hit submit to see if it works. Let's go for it. Okay, got it. Yeah, I didn't think hard enough about this. And like what they meant. Yeah, that's kind of an important thing. You have to like understand what they're even asking for a lot of questions. Oh yeah, okay. So the back is exactly what I thought it was. Yeah, I wasn't sure also about the queue. If I push into the queue, what ends up on the back of the queue? I push 3 elements in, A, B, C. Push A, push B, push C. What's in the back? I think A should be in the back. Or no. Yeah, C should be on the back. Right, that's exactly what I wanted. Yeah. In fact, I didn't need to use a queue at all for this. You could use a stack and just check a vector. Really, just check the stack. Check the pop. Oh no. No, you do want to use. No, you do want to use a queue. Yeah, queue keeps things simple here. Yeah, because you create the queue for one level and then you create the next queue based off of the previous queue. And check the last element in there. Is that entirely necessary? Kind of is. Yeah. Yeah, it kind of is. I wonder. You could just do. You could do something like this. The problem with appending null pointers in the queue, because I could just put a thing here to skip the null pointers. Right, you could rewrite this like this. However, the problem with doing it this way is the back is no longer guaranteed to be something that has a value. In fact, the back could just be a null pointer, and you have to actually probably scrub all the elements in the back that are null pointers out of there. Which is kind of funky, kind of wonky, but that would the intention is to eliminate this edge case and this extra code around here because there's like a few extra lines of code to kind of handle these null pointers I'm basically looking to skip null pointers as much as possible. Not even consider them. How can I do that? Let me think about it. It'll be a little bit cleaner, kind of semantically, if I could skip those null pointers. Let me ponder that some more. What can I do? Yeah, it's not really good, is it? No, I think I had it right the first time. It's actually probably easier to understand it this way. Let's make sure I didn't. Yeah, I think so. I think this is just better. Like I don't. Yeah. Because the problem you run into is you have a few things. You still have to push from the initial queue, right? And handle that case. This only sets up the next case, this while loop. And then you even still have the problem of like this whole piece just sets up the next level. And then this part is you have to have the back of the queue set properly. Which it kind of defeats the purpose of going level by level if you're just going to have all of those null nodes in there. I mean, you kind of want the whole point is to not think about those null nodes, I guess. Something like that. The reason why you do it this way is that you don't want to consider those null nodes. Yeah, I don't know. Yeah, okay. I mean, I guess we do it this way. Okay. All right. Fine. No, fine. I'm gonna spend too much time thinking about it, trying to figure out. I thought maybe I would spend a few minutes thinking about like maybe there's an obvious way to do it. But good look at the discussion. So yeah, this is how you do this problem one way. If you're on the right side, order from top to bottom. I screwed up on this. I shouldn't. My initial idea was really bad. Let's see what the discussions say. Traversal and user pointers. Oven, level order. Yeah, that's what I did. Push root, push G, indicator of level completion, previous pointer, Q empty, X left, right, Q front, Q pop, push last element of the result. P value, X equals G, empty, push, G not so we complete, left, right, left, push, update previous pointer. Q is not empty. That's kind of interesting how he did this. I'd have to kind of think about what he did here. X T tree node T. Okay. Left, right, Q pop. X is equal to G, so G is pointer, indicator of level completion, previous pointer, null pointer, X equals G, push the previous pointer value. Okay. If Q is empty, break. I didn't have to put all this on one line. I think this is a little confusing. This part. Oh no, excuse me. This is all one if statement. Okay. I mean, still kind of awkward, but okay. Can do that. Push back p value, wherever the previous pointer is pointing to. If Q is empty, break. Was push G. I'm not really sure what G is. X is set to the front. And you pop again. Completed a level. Okay. LT is X left, right T, RT is X right. Sure. Where does P get set? P is X. So initially X is not G, right? It can't be. G is a null pointer initially, so it skips initially. All right. Left is what X is pointing on the left subtree, right subtree. If the left subtree is not equal to G, which it won't be, push the left, push the right. P of X, updating previous pointer. Previous pointer is pointing to what X is pointing to. Okay, I think I understand. So where do we update G though? Do we ever update G anywhere in here? This is just a null pointer, G. But I think he pushes G somewhere into the queue. Yeah, that's interesting. So I think G is in the back of the queue, right? Right. Okay. I think I understand now. So you push the root onto the front of the queue, and then push G behind root. And so while you're processing the root, at some point you're going to hit G. So first you pop the root, you push the left, you push the right, onto, and you set the previous to what X was. So that's the root. And it's a queue. It's not a stack. So the G is next, and then left and right come after that. Oh, this is an interesting implementation. I like this. Oh, this is clever. Yeah, this is clever because you don't really care for. You just need, yeah. Okay, so he puts a marker in the queue for when he's at the end of the level, and then I was thinking that you could do something like this. I was like, I'm not sure exactly how, but I'm pretty sure you can. This is a lot better than what I was doing in terms of memory. This is a lot more efficient because you don't need to get the whole level each time. You just need the last element, and so just a marker for when you've finished the level is, and then a pointer to the thing that came before it is sufficient. I like that. Okay, this is clever way to do it. Okay, I was trying to understand exactly what he did. It took me a while to get it. Yeah, that's interesting. Just throw a marker into the queue to mark the end of the level. Nice, very good. And yeah, I mean, it's I don't know if it's that much more efficient actually. Excuse me, not thinking about it because I'm pushing all these elements. He's pushing a lot of these elements into the queue anyway, each level anyway. So it really isn't. So it's not that much more efficient, I guess. Yeah, actually, I take that back. I'm not really sure if it really matters that much. He's not. He's at least not creating a new vector every level, I guess. But that really shouldn't be much of an impact anyway. So, interesting solution. Not too much of a difference, but interesting no less. So I didn't mean to do that. Close these, I think. All right. Let's go back to the problem. So that's an interesting question. Interesting problem. Let me go ahead and end this stream here too. And we'll say thank you for watching, hanging out and saying hello. We do appreciate it. Talk to you all soon. I'm going to go to the next question. I'm going to restart the stream for the next question. So each stream is sort of like focused on each problem. Do it that way.